What's up, everyone? Today we're going to talk about one of my absolute favorite things in the entire world, quadratic functions. And we're going to start solving quadratic equations as well in this chapter. But first, we're going to look at graphing. So whenever I'm teaching solving equations, I love a new type of equation. I love to start by thinking about graphing because I think it's a perfect way to help us pair what's going on graphically with what's going on algebraically. So, let's go. Before we get started, I want you to do this little investigation here. So we are looking at two graphs, a linear graph and a quadratic graph, and I want you to just find and tell me what the x-intercepts are. So go ahead, take a second. All right, so you probably noticed that right here crosses the x-axis at like 1.5, and this quadratic crosses the x-axis at x's -4 and 1. Alrighty. So now I want you to solve this linear equation. I've taken that 2x minus 3 and set it equal to 0. So you're going to add 3 to both sides. We get 2x is 3. If we divide everything by 2, then we're going to get x's 3 halves, or 1.5, which is what we found above. Interesting. All right. Now I want to know if the x-intercepts that we found above -4 and 1 for that parabola, if they satisfy this equation, where I've just taken that quadratic expression, set it equal to 0. So let's see. We're going to plug them in. So we check this just by plugging them in and seeing if we get out 0. So I like to color code, so you'll often see me going in and writing everything out in one color and then going and filling it back in. So over here we had 1, over here we had -4. All right, so for -4 squared, we're going to have 16 minus 12 minus 4. So 16 minus 12 is 4, minus 4 is 0. So that one works out. Over here, we're going to have 1 plus 3 minus 4. So this will become 4 minus 4, also 0. So hey, they do satisfy this equation. Anytime a teacher says right, means there's something right there. All right, so what we're looking at here is that the real solution of a quadratic equation of the form ax squared plus bx plus c equals 0 and the x-intercepts of the graph of the related function are the same. So this is cool because it means that if we graph our function or we're looking at a graph, we know solutions to the equation once that equals 0, right, are just the x-intercepts. So that means we can use the graphing feature on our calculator to find these without having to solve by hand. So I'm going to tell you the steps for doing this on your TI, if you have a TI calculator, A4 or equivalent. But I'm going to show you how to do this on Desmos right here on my iPad because it's a little bit more efficient and more accessible too, because it's free. All right, so the first thing we're going to do is write our equation in the standard form, and we want it to be set equal to 0. All right, so just make sure everything's on one side, set equal to 0. Then we're going to graph the related function in our calculator. So we're going to take that quadratic expression, graph it in y equals. Then we're going to find the x-intercepts. That's the purpose of that whole investigation we just did. And we're going to hit second trace, which brings up calc, right? Calc is like the second function of that trace button. And then there's an option called 0 that we want to select. And then it's going to ask you a series of questions, like to the left of the 0, to the right, all that good stuff. And then you're going to have it guess your intercepts. And you'll have to do that once or twice, depending on how many solutions you've got going on. And then the solutions, or the roots, lots of interchangeable names here, of ax squared plus bx plus c equals 0 are going to be those lovely x-intercepts that you just found. Okie dokie, so this is where we're going to bring in Desmos. So here, we're going to solve each of these by graphing, and we're going to include a sketch of our graph as well. So I'm going to start just making some axes here, not doing anything crazy. All right, and I'm going to type in x squared plus 2x minus 3. All right, so one of the great things about Desmos is it's made by math teachers, right? So they're like, hey, I know that if someone's graphing this, they probably want to know the intercepts, both x and y, and the vertex of this thing. So if I just click on the function, notice how these gray dots start to appear. Those are those high frequency points that we tend to be concerned about. And we want these two right here, the x-intercepts. So cool, so much faster than working in TI. No shade to TI. I love TI, but this is just so efficient. All right, so I'm just gonna sketch, rough sketch here, what this quadratic looks like, and my intercepts here, where x is -3 and 1. Gorgeous. All right, so now we're gonna graph this next one. I'm gonna graph x squared minus 8x plus 16. All right. So you'll notice that this one is like sitting on the x-axis, right? The vertex is right there on the x-axis, like so. So it has one x-intercept here at 4. All right, so our last one had 2. This one has 1. All right, let's go ahead and graph our last one. So we got negative x squared minus 2x minus 4. And notice this one's not touching the x-axis at all. It's just going to keep going down, and it's never going to cross the x-axis. So, oof, that was a rough sketch. Anyways, the important thing here is that this guy's got no solution, where your teacher might accept this empty set here as well. All right, well, that's so interesting. So what we're going to do now is summarize what's going on here. So we've got our possible number of real solutions here. There's going to be 3 options, right? So we can have 2 solutions like we had above, 1 solution, or we can have no solutions. And we're just going to sketch what that could look like. So don't think you have to just copy my sketch that you here. You guys are brilliant minds. You can come up with your own examples. All right, so 2 solutions. It's going to have to cross at 2 points somewhere. So mine's going to look like this. Alrighty. Next one has 1 solution, so maybe it crosses right there. Alrighty. And then for none, maybe it's like this above the x-axis. It's not going to cross the x-axis anywhere. Alrighty, so go ahead and try example 2 here. You're going to graph these on your own, on your calculator, on Desmos, and then you're going to go ahead and sketch them and tell me what your intercepts are. Notice that this guy here, right, is not set equal to 0, so you'll have to do some finagling first before you do that. Hey, I noticed you didn't pause the video and try these out. Go ahead, actually pause the video, try these prompts out, and then come back to me, okay? All right, so this one here. Oops, I meant to split my screen. What am I doing? All right. Okay, so here we go. 4x squared minus 2x plus 5. All right, so this guy has, oh, where's my x-axis? No solutions. All right. Again, you can use the empty set as well. All right, so for this last one, we move everything over. So I'll have 4x squared minus 4x minus 3 equals 0. You're probably wondering what happens if we had moved the x squared over instead. So it was negative x squared plus 4x plus 3. And so what's going on here is these are actually just x-axis reflections of one another, but the intercepts remain the same. Oh, isn't that such a pretty picture? I love graphing. Anywho, they end up having the same x-intercept, so it doesn't matter if you moved everything to the right, you moved everything to the left. So cool. So cool. I love math. All right, so I'm gonna sketch mine as being the positive one because it's what I have written down here. But again, the x-intercepts are the same. Let's round to 2 decimal places. Sounds good. So we're going to have negative, 0.65. Don't worry. I looked at them before they disappeared again. And 4.65. All right, everyone, that's how we're going to go about solving these beautiful quadratic equations by graphing. That's the first of our 5 methods that we're going to talk about. And I'll see you next time. Bye.